put a nice little VOD for me at the end. Okay. Cool. Oh, we're dropping so many frames right now. Tragic. Cool. Onward and upward, folks. Onward and upward. It'll be up on YouTube later. If the stream gets too gross and you want to still watch the content, I will be putting this up on YouTube later. So, a document created in these rich text editors has more than just embedded text in the file. These files also contain information on how to display the text on screen. In contrast, plain text editors such as VS Code and Sublime don't add any additional information, saving only the text. And saving only the text allows other programs like Ruby's interpreter to read and execute the file as code. You can think of code editors as specialized web development tools. They are highly customizable and offer many features that will make your life easier. There's nothing worse than spending 2 hours trying to figure out why your program isn't working, only to realize that you missed a bracket. Can attest. It's frustrating. Finding just a simple typo is like, this whole time. No. Plugins, syntax highlighting, auto closing brackets, and braces, and linting are just a few of the benefits of using a code editor. There are many text editors out there to choose from, but we suggest starting with Visual Studio Code. So VS Code is commonly referred to. It's an excellent free code editor. It has outstanding add-ons and great Git integration. VS Code is the most popular code editor among Odin students and moderators, so support is easy to find in this community. Which editor you use generally is a matter of preference, but for the purposes of this course, we're going to assume you're using VS Code, mainly because it's free, easy to use, and it works pretty much the same on every operating system. Keep in mind that this means you will not be able to get help if you're using a different text editor other than the VS Code for the curriculum. As a reminder, if you're using a virtual machine, you should install this on your VM. That's what I'm going to be doing. And you're welcome to install it on your host as well, but you'll want to make sure that you have this inside of your VM. So, here is the installation guide. So we're going to click on Linux, and that's going to drop this guy down. So, we're going to terminal, and then here we're going to copy this, and then we're going to paste, and then we will run it. So that's just pulling the most recent VS Code installation methods. While that is running, right quick, I'm going to turn the side lamp on because it is a little dark, but I will be back in just a jiff. Might not look like much now, but it is going to help a lot. It'll warm up. The light bulb will warm up and help us out. It's also really chilly in my house, so I'm going to wear a blanket unless it looks really silly. I'll see here in a couple seconds if it looks horrible or not. Looks like we're lagging again. Tragic. Cool. And we're back. Cool. So our download has completed. We're gonna copy and paste. and our password. There we go. And we're going to wait for that to do its thing. So, one thing that I did want to touch on, I had missed somehow in our former streams, is the roadmaps. So, this was linked in a previous Odin project lesson. Sorry, my words are failing me. Previous Odin project essay lesson. Oh my goodness, I cannot speak today. And so these are basically just a bunch of skill paths, and OBS disconnected again. Are we back? OBS? Are we back? I think we're back? I think we're back. We're back. Okay, cool. I'm gonna have to, after today, I'm gonna look into why that's happening, because that's obnoxious. But these paths just give a lot, like a front-end dev. If I load into here, it'll show this roadmap of things that I need to learn. It'll show like you need to learn how the internet works. So if you click into here, it has all of these articles and videos on what to learn there. You can mark your progression through these. So as a resource outside of Odin project, or if there's something that we want to go further into that Odin doesn't necessarily touch on, this is a great place to kind of poke through, and they have tons of them. They have front end, back end, software architect. Like you can see, I don't need to read all of them, but just like really great. Like once I finish the Odin project, my plan is to work through an algorithms textbook, and probably as I'm getting into the material and it starts to talk on like structuring code and data structures, but this computer science roadmap will be really helpful. Design system, yeah, just a really cool resource that I had neglected to overview for y'all, so wanted to just bring that up. Highly recommend checking that out. So we had completed this step, entered our password, now it has completed. And this note did appear, so download is performed on Sandbox's root file, and it says not to worry about it, so I'm not going to worry about it. Now we'll delete the installer file. And that's just paste. Just kidding. Paste, and I'm going to delete. Paste. There we go. Maybe? Yes. We're going to say that that's great. Okie dokie, now we're going to type in code to the... There we go. I was like, why no do? I make this a little skinnier. Put it up next door, right here. So advanced users might want to install VS Code using the built-in apt package manager, allowing VS Code to be kept up to date automatically, and that can be found on this web page. I am not an advanced user, so I might just come back to that later. advanced setup VS Code in case I need it for later. Alrighty. So our assignment for this is to familiarize ourselves with the VS Code, allowing us to save time and become more productive. Watch this VS Code tutorial for beginners and we'll get an idea of all of the features that it has to offer. So I'm going to click on that, it's going to load, and I'm just going to pause it immediately. I'm really hoping it's kind of corny, just like the other ones were. It's going to show you all my YouTube recommendeds. Okay, cool. Back to the beginning. Now we'll just look at the additional resources. So the docs are great. I'm gonna open those, and then there are shortcuts for Linux for VS Code, which are also good. So I'll open that as well. And we'll start with the video, just because that's going to be the first resource that was recommended to us. So I'm going to start with that and move on from there. Here we go. Ooh, sponsor. I'm gonna skip over that. Ah, not the whole video, no. Looks like OBS decided to poop out again. I'm going to pause here. There's a get started page on the VS Code that I'm actually going to complete before we do anything else. So I'm going to choose our browser colors, or our theme colors. Ooh, what's red? I kind of like it, not gonna lie. I'm just gonna look at all of them because I do like a good theme. So these are all the dark themes. Ugh. I'm not a huge fan of that one. Maybe not the high contrast for me. What is the light? Ooh, it's too bright. My eyes. My eyes. It's kind of boring. I kind of like the brown. The brown's kind of nice. I kind of like that. Monokai. OBS disconnecting again, OBS reconnecting again. You know, I'm gonna go with the red, I think. I think I really like the red, actually. Yeah, so we're gonna go with the red. That's gonna be my cool mark this one as done. Okay, OBS is having a party over here. Gonna just Google why that might be happening. You know, the Google. Be my friend. OBS crashing. Stream. Alright, how to stop OBS from crashing. So it's often graphics card or outdated versions. So you can reinstall OBS. Which I might do after today. There's this tool they recommend. We'll see if I do that. Faulty or out of date software. So I'll just potentially re-download. I know that when I had downloaded, or when I had most recently opened OBS, my graphics drivers were out of date, so I had updated all my drivers. But I don't know if that means that it was an old version of OBS. Cool. It looks like we crashed again. Crashing again. Amazing. We're back, maybe. This is kind of unviewable, I think, because it keeps crashing so much. So I'm going to just take a note of the settings that I have in OBS so that I can redo those, then re-download OBS. So hopefully I will be back in like a half hour after setting all that up, and I am so sorry. Yeah. It's a mess. Proper mess. Alright. See you in a bit. Okay. So I've tried just, you know, uninstalling and reinstalling OBS. We'll see if that fixes the issue. It might not, because, you know, it might not. But that's the first thing that I can think of to check. So we will continue along our merry way. Cool. So we were talking about Virtual Studio Code. So I'm going to just jump right back into that. And here we go with this vid. Oh my goodness. Oh, that's really thinking. Death to the terminal! Whoa. Yeah. Mm. Cool. Mm. I'm gonna pause. Sorry I haven't really been talking much. I've just kind of been listening to him do his thing. But I'm gonna poke in here to extensions and actually look for that extension. Prettier code formatter install. And then I'm gonna continue watching while that does its thing. That's cool. Yeah, no. Sweet. Oh, that could be very useful. Ooh. Super nice. Mm. Mm. Oh. My eyes. Mm. No. Okay. Just pausing while OBS is down. OBS is still down. We're still down. All right, we're reconnected. Cool. Almost through it. Oh, it keeps going. Okay. Yeah. That outro's a little loud. Cool. There's a lot in there. So I might have to go back and just jot down all those shortcuts and things for later, but it was good to get an overview. I'm gonna go back and OBS is disconnected again. Oh, and we're back. We're back. OBS is back. Alright. I'm going to mark this lesson as complete because we watched the primary marking as complete because we watched the primary video about how to use VS Code. It did definitely give me an idea of all the features, but I would need a lot of practice to continue to actually use it. Anyway, so here is the list of the shortcuts, which is super useful, really good to have. And then here is just a guide for VS Code, also super useful. I may keep that open for a little while. We're going to move on to the next lesson while OBS is working, because we never know how long it's going to stay up for. Here are command line basics. So, introduction. Feeling scared of the command line? You're not alone. We have this image of developers starting an entirely blank screen with the white or green text flashing across as they enter incomprehensible commands to hack the corporate mainframe. Da da da! Like all of those spy movies. That black screen or window is the command line interface, CLI, when you're able to enter commands that your computer will run for you. While there's no need for you to reenact the scene above, I don't get to hack the mainframe? Come on. Working within the command line is critical skill for you to learn as a developer. The command line is like our base of operations. We'll launch other programs and interact with them. It has a syntax of its own to learn, but since you'll be entering the same commands dozens of times, you'll quickly pick it up. In this lesson to the command line, you will learn how to navigate around your computer and manipulate files and directories known as folders, directly from the comfort of the command line. You'll soon see that this isn't as difficult as you may think. The commands you will learn in this lesson are very straightforward, so don't let the prospect of using the command line for the first time intimidate you. So, opening a terminal on your computer, so we can do this by hitting Control-Alt-T, so I'm going to do that now, Control-Alt-T. But I already had a terminal open, so I'm just going to close one of them. Alright, and then I'm going to minimize. Don't need that open right now. So we'll pull this over here, and then make this a little more narrow. So now we have our terminal open, so that shortcut is Control-Alt-T. Much faster than the alternative way of going into the whiskers menu, waiting for it to load, and then clicking on the terminal emulator. That is another way to navigate to the terminal, but the Control-Alt-T is much faster. And again, I'll be using all of the Linux instructions for this because I am operating a VM in Linux. So, before we do anything, let's take a look at the following text. So it starts with a $sign and then who am I? This is a terminal command because it begins with a $sign. It is saying, hey, enter what follows in your terminal. And you can see in the terminal, I'm just going to hover over with my mouse. There is the $sign in the actual terminal. So what this means is we must exclude the $sign when entering any command. I totally lost my place. There we go. In the example above, we would only enter who am I, which would be the actual code that is executed by the command Now that you're aware of what the $ does, take your terminal for a test run. Make sure your terminal is open and copy the command above, and then press enter on your keyboard. So we're just going to type who am I and then enter, and it returns my username, which is exactly what it says in the Odin project screen. So yay, we did it right. So why is learning this now important? You'll make heavy use of the command line throughout this curriculum, and the upcoming installation project will need you to install many different software programs using the command line. Additionally, you will primarily be using Git within the command line. More on that later. As part of the bigger picture, you may well be using the command line on a daily basis in your career as a software developer, making it an indispensable tool in your toolset. So here's the lesson overview. This section is just what we'll learn in this part of the lesson. So what is the command line, and then how to open the command line on a computer, use the command line to navigate directories and display contents, and then use the command line to navigate or to create new directory and a new file, use the command line to rename or destroy a file or directory, and then use the command line to open a file or folder in a program. So our assignment now, many of these resources assume you're using Mac or Linux environment. If you did our previous installation lesson, you should already have Linux installed in a dual boot or a virtual machine, or you might be using Mac OS. If you don't have Mac OS or any version of Linux installed, please return to the OS installation guide. Visit the Unix Shell course designed by the Software Carpentry Foundation. I will open that now. I'm going to exit out of the VS shortcuts because we are not currently using, I'm actually going to exit out of Virtual Studio because I don't believe we'll be using it for this lesson in particular. So for the Unix Shell course designed by Software Carpentry Foundation, there will be a full complement of lessons on it, on using the CLI. But for now, just complete the following lesson. So setup, introducing the shell, navigating files and directories, working with files and directories, pipes, and filters. So I'm going to write those down just so that I have a record of them. So once I'm over there, I don't have to keep tabbing back and forth. So we're going to do setup, and we're going to do introducing the shell. And navigating files. I'm so pleasantly surprised. It seems like OBS is behaving. As soon as I've said that, it's going to disconnect. But for now it's working. All right, working with files and directories, and then finally pipes and filters. It seems like the stream is pretty quiet right now, actually, which I might take advantage of. No, we're still going strong. So I'm gonna just continue at it. So, Unix shell. And then once we're back from all of those lessons, we're going to continue with the second part of, oh, we disconnected. And we reconnected. Why? Okay, we're back. I kind of hope OBS is still recording when it does the little like in and out like that, because my reactions I think are pretty funny. I have this like exasperated sigh and I'm like, OBS no! So for uploading the VOD to YouTube later, it would be really funny if all of those reactions are being recorded. I really hope that they are. Anyway, so once we're done with all of the Unix shell lessons, we're going to come back and practice creating the following folders. Yeah. Yep. So here's the Unix shell. It's been around longer than most of its users have been alive. It survived because it's a powerful tool with a few keystrokes or lines of code. It helps users automate repetitive tasks and easily combine smaller tasks into larger, more powerful workflows. We just disconnected again. Okay, that's my cue. I'm going to see if there's an Ethernet cable in the living room. Once we're back, I'm going to let you know what's going on. I think we're back. I'm going to check my living room right quick to see if there's an Ethernet cable, to see if I can get this network to work a little bit better. So there's going to be some dead air, and I will be right back, hopefully with an Ethernet cable to make this work a little bit better, because right now I'm on Wi-Fi and it's dropping me. So I'll be right back. Good news and bad news. I found an Ethernet cable, but it is not long enough. So we're going to continue on our merry way with all of the drops, and I will just upload the VOD later. And figure out further next steps for how to fix the problem longer term. Alright. Jumping back in. Alright, so setup. It's going to be our first lesson. You'll need to download some files to follow this lesson. So we're going to download this. Huzzah. And then we're going to unzip and extract this file. Let your instructor if you need help with, well, cool. Opening looks like great. Have done. I'm gonna exit out of this one. Cool, and if you don't already have the shell installed, you'll need to download and install it. I don't know that I actually have this installed. To see if you have echo shell. Okay, so I think that we might have it because it says bin bash, and that's what it says. So I might just proceed. Okay, so open a terminal, and that is Control-T. is the shortcut that we would use for that, but we have a terminal open already. In the terminal, we're going to type cd and then press return. And this step, make sure you start with your home folder as your working directory. Cool. So in this lesson, you will find out how to access data files in this folder. So where to type commands, how to open a new shell. The shell program that enables us to send commands to the computer and receive output. It is also referred to as the terminal command line, which we have open here. So this is our shell. Some computers include a default Unix shell program. The steps below describe some methods for identifying and opening a Unix shell program if you already have one installed. There are also options for identifying and downloading a Unix shell program, a Linux Unix emulator, or a program to access a Unix shell on a server. If none of the options below address your circumstances, try an online search for Unix shell, your computer model, your operating system. So we're going to click on Linux. The default Unix shell for Linux is called Bash. On most versions of Linux, it is accessible by running the GNOME terminal or KDE console or Xterm, which can be found via applications menu or search bar. If your machine is set up to use something other than Bash, you can run it by opening a terminal and typing bash. Bash. Great. So I think that this is fine. I think that we have completed this. So I'm going to go back. I'm going to take my pen and cross out setup because we have done that. I believe we have done that. So we're going to introduce the shell. Introducing the shell. Questions are, what is a command shell and why should I use one? And then objectives are how to explain how the shell relates to the keyboard, the screen, the operating system, and user programs. Explain when and why command line interfaces should be used instead of graphical interfaces. So, background. Humans and computers commonly interact in many different ways, such as through a keyboard and mouse, touchscreen interfaces, or using speech recognition systems. The most widely used way to interact with a personal computer is called a graphical user interface, a GUI. With a GUI, we give instructions by clicking a mouse and using a menu-driven interaction. While the visual aid of a GUI makes it intuitive to learn, this way of delivering instructions to a computer scales very poorly. Imagine the following task. For a literature search, you have to copy the third line of 1,000 text files in 1,000 different directories and paste it into a single file. Using a GUI, you would not only be clicking on your desk for several hours, but you could potentially commit an error in the process of completing this repetitive task. This is where we take advantage of the Unix shell. The Unix shell is both a command line interface, CLI, and a scripting language, allowing such repetitive tasks to be done automatically and fast. With the proper commands, the shell can repeat tasks with or without some modification as many times as we want. Using the shell, the task in the literature example can be accomplished in seconds. Very fancy. The shell. The shell is a program where users can type commands. With the shell, it's possible to invoke complicated programs like climate modeling software or simple commands that create an empty directory with only one line of code. The most popular Unix shell is Bash, standing for the Born Again shell, so called because it is derived from a shell written by Stephen Bourne. That's cool. Bash is the default shell in most modern implementations of Unix in most packages that provide Unix-like tools for Windows. Using the shell will take some effort because it will take some effort and time to learn. While a GUI presents you with choices to select, CLI choices are not automatically presented to you, so you must learn a few commands like new vocabulary in a language you're studying. However, unlike spoken language, a small number of words get you a long way, and we'll cover these essential few today. So I'm going to pull out, I have this very old legal pad, very fancy. And I'm just going to write some of these down because writing things down physically helps me remember them best. It's my way of studying. Later on, when I get into the algorithms book, I will have a bunch of notes on pages like these that I will be describing to you as we go through problem sets, if I eventually make it that far. I'm hoping so because it would be really cool. Anyway. Cool. We'll cover those essential few today. Grammar of a shell also allows you to combine existing tools into a powerful pipeline and handle large volumes of data automatically. Sequences of commands can be written into a script, improving the reproducibility of workflows. In addition, the command line is often the easiest way to interact with remote machines and supercomputers. Dun, dun, dun. Familiarity with the shell is near essential to run a variety of specialized tools and resources, including high-performance computing systems. As clusters and cloud computing systems become more popular for scientific data crunching, being able to interact with a shell is becoming a necessary skill. We can build on the command line, skills covered here to tackle a wide range of scientific questions and computational challenges. Super exciting! Let's get started. When the shell is first opened, you are presented with a prompt indicating that the shell is waiting for input. It's the $, which we had seen before. I used to work in a lab, and a lot of the more complex liquid handling robots would sometimes show their scripts that they were running. I was very confused because they ran everything started with that $. I was super confused, but this makes some more sense that it was actually the command line processing all of the different inputs from the server side. That's my best guess, but it makes sense to me, and it's kind of exciting to kind of put that together a little bit. All right. The shell typically uses $, as the prompt, but may use a different symbol. In the examples for this lesson, we'll show the prompt as $. Most importantly, when typing commands, either use these from lessons or from other sources, do not type the prompt. Only the command that follows it. Also note that after you type a command, you have to press the enter key to execute it, because otherwise the computer still thinks you're typing. The prompt is followed by the text cursor, a character that indicates the position on. Just gonna wait a second because OBS just disconnected again. Looks like we're reconnected. Okay, back into it. A character that indicates the position where you're typing will appear. The cursor is usually flashing or a solid block, but it can be an underscore or a pipe. You may have seen it in a text editor before, for example. So let's try our first command, ls. So I'm going to type this down. Not type it down, write it down. So our first command is ls. This command will list the contents for the current directory. So I'm just going to put into our command line here, ls. And it looks like we have desktop, documents, downloads, music, pictures, public, snap, templates, and videos, which looks very similar to what we have listed here, just with a couple extra, couple missing. Super cool. So, command not found. If the shell cannot find a program whose name is in the command you type, it'll print an error such as this. The text that you had typed and then command not found. This might happen if it was mistyped or if the program corresponding to that command has not been installed. So, NEL's pipeline. A typical problem. Scrolling down, here we go. Nell Nemo, a marine biologist, has just returned from a 6-month survey of the North Pacific Gyre, where she has been sampling gelatinous marine life in the Great Pacific Garbage Patch. Delicious. She has 1,520 samples that she's running through an assay machine to measure the relative abundance of 300 proteins. Super cool. She needs to run these 1,520 files through an imaginary program called goosestats.sh she inherited. On top of this huge task, she has to write up results by the end of the month so her paper can appear in a special issue of Aquatic Goo Letters. Such a cool publication. I would read that publication for sure. The bad news is that if she has to run GooStats by hand using a GUI, she'll have to select and open a file 15-20 times. And that is 1,520, not 15 to 20. If GooStats.sh takes 30 seconds to run each file, the whole process will take more than 12 hours of Nellie's attention. With the shell, Nell can instead assign her computer this mundane task while she focuses her attention on writing her paper. Super helpful. The next few lessons will explore the way Nell can accomplish this. And I know I'm going back and forth between saying Nell and Nellie, but I don't know which one it is, so I keep saying different ones to hopefully get it right on half of the time. More specifically, they explain how she could use a command shell to run the GooStats program using loops to automate the repetitive steps of entering file names so that her computer can work while she writes her paper. As a bonus, once she has put a processing pipeline together, she'll be able to use it again whenever she collects more data. In order to achieve her tasks, Nell will need to know how to navigate to a file directory, check the file directory, create a file directory, check the length of a file, chain commands together, retrieve a set of files, iterate over files, and then run a shell script containing her pipeline. Key points to take away. A shell is a program whose primary purpose is to read commands and run other programs. This lesson uses Bash, the default shell in many implementations of Unix. Programs can be run in Bash by entering commands at the command line prompt. The shell's main advantages are its high action to keystroke ratio, its support for automated repetitive tasks, and its capacity to access networked machines, like I had said earlier with those Hamilton liquid handlers. The shell's main disadvantages are its primarily textual nature and how cryptic its commands and operations can be. So, we have just finished introducing the shell. Boop. We're going to move on to navigating. So, this is our next one. So, navigating files and directories. Here we are. Questions to answer in this lesson. So, how can I move around my computer? What files can I see? How can I see what files and directories I have? How can I specify the location of a file or directory on my computer? And then key objectives for this lesson: explain the similarities and differences between a file and a directory, translate an absolute path into a relative path and vice versa, construct absolute and relative paths that identify specific files and directories, use options and arguments to change behavior of a shell command, and then demonstrate the use of tab completion and explain its advantages. So here we go. Okay. The part of the operating system that is responsible for managing files and directories is called the file system. It organizes our data into files which hold information, and directories, also called folders, which hold files or other directories. Several commands are frequently used to create, inspect, rename, and delete files and directories. To start exploring them, we'll go to our Open Shell window. Dun, 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 dun. OBS just disconnected, so we're going to wait for a second until it reconnects because I want this information to be included in the VOD. I'm wondering how long my Ethernet cable has to be, or if they have like super long ones, because I could just run it from the living room into my room whenever I'm streaming, because that might be the plan. Anyway, so we're back to it. First, let's find out where we are running a command called pwd, which stands for print working directory. Directories are like places. At any time while we are using the shell, we are actually in one place called our current working directory, CWD. Commands mostly read and write files in the current working directory, i.e. here. So knowing where you are before running a command. Oh, we just disconnected again. And I think we're back again? Part 17. What a mess. All right, PWD shows you where you are. So I'm going to go ahead and type that. PWD. Part 18, let's go. So we just learned the command pwd. I'm writing that down. So ls just shows directories, and then pwd shows current working directory. Cool. I've written that down. So we've got our current working directory here is home and then Unleashed Dragon. So that's me on my computer. Now, in this example, it was actually Nell because Nell is the person working on her Goo studies. And then home directory variation. The home directory path will look different on different operating systems. On Linux, it may look like \home\null. On Windows, it might look like C:\documents and settings/null or C:\users/null. Note that it might look slightly different for different versions of Windows also. In future examples, we've used Mac output as default. Linux and Windows may differ slightly, but should look generally similar. We will assume that your PWD returns your user's home directory. If it returns something different, you may need to navigate there using cd, or some commands in this lesson will not work as needed. So cd was another one that I'm going to write down. And I think that was current directory. And then bash just ensures that we are in bash. Cool. Moving on. There is a lesson called Exploring Other Directories, which focuses more on the cd command, which we might do at some point, but not right now. To understand what a home directory is, let's have a look at how the file system as a whole is organized. For the sake of this example, we'll be illustrating a file system on our scientist Nell's computer. After this illustration, you'll be learning commands to explore your own file system, which will be constructed in a similar way, but not entirely identical. On Nell's computer, the file system looks like this, shown below. So there's the \bin data users tmp. At the top is the root directory that holds everything else. We refer to it using a / character. On its own, this character is the leading slash in /user/null. Inside of that directories are other directories. Bin, which is where built-in programs are stored. We're pausing for a second while OBS reconnects. Cool, we're back. Data for miscellaneous data files. Users, where user personal directories are located, and then TMP for temporary files that don't need to be stored long-term, and so on. We know that our current working directory, users /users/null, is stored inside of the /users because /users is the first part of the name. Similarly, we know that users is stored inside of the root directory because / begins its name with /. Classic. Alright, slashes. There are two meanings for the / character. When it appears at the front of directory or name, it refers to the root directory. When it appears inside a path, it's just a separator. So underneath /users, we find one directory for each of the users on Nell's machine, her colleagues Imhotep and Larry. As you can see in the little diagram. The user Imhotep's files are stored in that folder, Larry's are stored in that folder, and Nell's are in that folder. Nell is the user in our directory example here, therefore we get Nell as our home directory. Typically when you open a new command prompt, you will be in your home directory to start. Now let's learn the commands that let us see the contents of our own file systems. We can run what's in our home directory by using ls. I'm going to just clarify. So ls means showing directories in home directory. Great. So in our bash console, we've already done this, ls, and it results in all of our different file directories. Our results might be slightly different depending on our operating system and how we have customized our file system. ls prints the names of the file and directories in the current directory. I am saying directories so many times. And hi Diggs, by the way, 7. It's good to see you. We can make its output more comprehensible by using the -f option, which tells ls to classify the output by adding a marker to file and directory names to indicate what they are. Oh, excuse me, had a yawn. Okay, a trailing slash indicates that it is directory, @ indicates a link, and then apostrophe, asterisk indicates an executable. So we're going to do that now. I'm going to write down our new, so ls -f yields indicates what the files are. What they are. So we're going to do that. We're going to do ls and then -f return, and so this returns a whole bunch of stuff. So .profile, pictures, defaults, desktop, screensaver, music, public, documents, etc. Depending on your default settings, the shell might also use colors to indicate whether each is a file or directory. And OBS just disconnected again. OBS is back, it seems. Very cool. All right. What a mess. What a mess. Okay. So now here we can see that all of our home directories also contain a subdirectory. You can clear your terminal using the clear command, and you can still access by hitting the up and down arrows to move line by line. So I'm going to write that down too. Clear is going to be a useful one, so C-L-E-A-R, clear, clears the terminal. This always reminds me of the text game. Oh, why am I blanking on its name right now? Super classic text-based game that I'm not thinking of the name of. But it looks like a command line, and you have to tell the computer what to do in that game in order to use it. Getting help. LS has a lot of other options. There are two main ways to find out how to use a command and what its options are. Depending on your environment, you might find that only one of these ways works. We can pass a --help option to the command available in Linux and Git Bash, such as ls-help. So I'm going to write that down. So that is ls-help get help. And then man space ls gives us the manual. So we'll describe both ways next. So the help option, both Bash commands and programs that people have written to run from within Bash support a help option that displays more information on how to use the command or program. So ls-help. The output will be usage ls option file, list information about the files, the current directory by default, sort entries alphabetically if neither nor sort is specified. Mandatory arguments to long options are mandatory for short options too. So here's a list of dashes. So lowercase a is all, do not ignore entries starting with. Uppercase is almost all, do not list implied, and then author is with L, print the author of each file. B or escape is print C-style escapes for non-graphic characters, and then block size equals size, scale sizes by size before printing them. I'm going to stop reading through this, but the output is very helpful. It's just a bunch of information on all of the things that can be used, or the ways that we can interact with that program or option. So unsupported command line options. If you try to use an option that is not supported, ls and other commands will usually print an error message similar to this is invalid. Try ls-help for more information. Very good to know. Now the manual command. Another way to learn more about ls is to type man space ls. This command will turn your terminal into a page with descriptions of the ls commands and its options. To navigate through the man pages, you may use up and down arrows to move line by line, or B and space bar to skip up and down full page. To search for a character or word in the man pages, use / followed by a character or word you are searching for. I'm going to write that down right quick. Search manual, search manual / word. Great. Sometimes the search will result in multiple hits. If so, you can move between using N to move forward and then Shift N to move backwards. To quit the manual pages, press Q. So I'm just going to type this in now so we can see it. Man ls, enter, and then that is this. So we can just move line by line like this. And then we can use space or down. And then we can press Q. I just pressed Q to quit out. All right, manual pages on the web. Of course, there's a third way to access help for commands, searching via the internet browser. When using internet search included in including the phrase Unix man page in your search query will help find relevant results. The GNU provides links to its manuals, including core GNU utilities, which cover many commands introduced within this lesson. You can use two options at the same time. What does the command ls do when using the -l option, -l option? What about if you use both -l and -h? So we're going to try this right now. So we're going to use ls. So that just gives us what looks like a list of our directories, and then when they were either created or last accessed. And then we're going to do ls -l -h. And this looks pretty much the same, only it is, it had changed our, it's giving the file size, I believe, and in just a different format. Some of the outputs is about properties we don't cover, such as file permissions and ownership, but the solution will be useful nonetheless. So ls use a, just gonna wait. We're waiting. So I was right. It does make a list. Looks like it's not coming back. Cool. There we go. Came back. All right. So the -l makes a long list format showing only the file, not only the file directory names, but also additional information such as file size and the time of its last modification. So that's kind of what I had said. And then if you're using both the H and the L option, it makes the file size human readable, displaying something like 5.3K instead of 5369. Which is also what I had said. It changed the way that it displays. So listing in reverse chronological order, by default, ls lists the content alphabetical by name. The command -t lists items by last change instead of alphabetically, and then -r lists the contents in reverse order. So which file is displayed last when you combine the -t and -r options? You might need to use the -l option to see the last change dates. So we're going to type in here our ls and then use -l and then use -t and -r. And this should give us our like history of files. So we have our long list, our long format list, and then you can see listed first is our oldest, and then followed by our newest, which would be the desktop, which was edited. I dragged and dropped this right here onto the desktop at 104, as is listed right here. So we're looking good. We're looking good. We'll click open this. So yeah, the most recently changed file is listed last while using, oh, and you don't have to, I'm going to do it again. I'm going to do it again. So ls and then lrt. It does the same exact thing. Amazing. I like that. I like that shortcut that you don't have to do a dash every single time. You can combine without having to do that. It's great. All right. Exploring other directories. Not only can we use ls on the current working directory, but we can use it to list contents of a different directory. Let's take a look at our desktop. I'm going to clear this because it's a little nutty. So I'm just going to hit clear, and that's going to make it look very much nicer. So not only can we use ls on the current working directory, but other directories as well. Let's take a look at our desktop directory by running ls capital F desktop. And that gives us shell lesson data, which is exactly what is listed here. So note that if a directory named desktop does not exist in your current working directory, this will return an error. Typically, a desktop directory exists in your home directory, which we will assume is the current working directory of your bash shell. Your output should be a list of all the files and subdirectories in your desktop directory, including the shell lesson data you downloaded for the setup for this lesson. On many systems, the command line desktop directory is the same as your GUI desktop. Take a look at your desktop to confirm that your output is accurate, and it is. As you may now see, using a bash shell is strongly dependent on the idea that your files are organized in a hierarchical file system. Organizing things hierarchically in this way helps us keep track of our work. It is possible to put hundreds of files in our home directory, just as it is possible to pile hundreds of printed papers on your desk, but it is a self-defeating strategy. Now that we know the shell lesson data directory is located on our desktop directory, we can do two things. First, we can look at its contents by using the same simple strategy as before, passing directory name to ls. So here we are going to type in ls-f and then space desktop slash shell lesson data. And that returns exercise data / North Pacific Gyre. Secondly, we can actually change our location to a different directory so we're no longer located in our home directory. The command to change locations is cd followed by a directory name to change our working directory. CD stands for change directory. I'm going to write that down because I had it written wrong. Not current. Change directory. Good stuff right there. Alright, so CD stands for change directory. And what we will do now is we're going to put in CD, change directory to desktop. So now we are at desktop instead of just our home directory. Let's say we want to move the data directory we saw above. We'll take the following series of commands to get there. So we just moved into our desktop directory, and now we're also going to move into change directory to shell lesson data. Now we're in shell lesson data, and then we're going to go one step further, and we're going to go into exercise data. Now we are actually inside of the folder. We are in our desktop directory. We are in the file directory shell lesson data, and then we've gone one step further into the file directory exercise data within shell lesson data. Wow, speaking sometimes it gets me every time. Somebody's honking. Okay. Then we're going to pwd, which means show current working directory. So pwd. Oops. pwd. And that gives us our current directory. And now we will ls So -f gives us animal counts, creatures, proteins, and writing. So I'm going to write down -f. I already did that. Yay! Cool. We now know to go down the directory tree, but how do we go up? how do we leave a directory and go into its parent directory? So we might try the following, but it will return an error because the shell is going to look further into the directory and no such file is going to exist unless we have a similar file name within our directory further down. So with our methods so far, cd can only see subdirectories. There are different ways to see your directories above your current directory location. So we'll start with the simplest. There's a shortcut in the shell to move up one level that looks like this. So cd ... is a special directory name with the directory that comes before this one, or more specifically, the parent of the current directory. Sure enough, if we run pwd after running cd, we're back in shell lessons data. The special directory doesn't usually show when we're running ls. If we want to display, we can add a -a option to -f, which will look like that. I am getting really antsy. I need to take a break, so I'm going to hop off. I might be back to finish out the last couple of minutes, but I am just going to be back after a little while. So. Okay, so just finishing out the last end of the stream. I'll go over some more of this lesson and then do a quick recap of what we learned today, of all that we did today. -a stands for show all, so I'm going to write that down. -a stands for show all. Which we can also see if we look in the --help. It forces ls to show us file and directory names that begin with dot, such as .. which, if we're in user nel, refers to the user's directory. As you can see, it also displays another special directory. I feel like I missed something. Okay, yeah. Okay, the special directory only shows up if you use -a, so it's just showing all. Got it. As you can see, it also displays another special directory called dot, which means the current working directory. It might seem redundant to have a name for it, but we'll see some uses for it soon. Note that in common command line tools, multiple options can be combined with a single dash and no spaces between the options. ls-f-a is equivalent to ls-fa, which is really nice. They had shown that earlier. So other hidden files. In addition to the hidden directories ... and dot, you might also see a file called .bash profile. This file usually contains shell configuration settings. You may also see other files and directories beginning with dot. These are usually files and directories that are used to configure different programs on your computer. The prefix dot is used to prevent these configuration files from cluttering the terminal when standard ls command is used. These three commands are basic commands for navigating the file system on your computer: pwd, ls, and cd. Let's explore some variations on those commands. What happens if you type cd on its own without giving a directory? So that just returns us to the base directory, I believe. So yeah, it returns us back to our base directory, which would be our current home user, the home of the current user, which would be me, so Unleashed Dragon. Turns out cd without an argument will return you to your home directory, which is great if you've gotten lost in your own file system. Let's try returning to the exercise data from the directory. Last time we used 3 commands, but we actually can string together the list to move to extra data in one step. So it's going to look like change directory desktop / shell lessons, helps if I type it right, lesson data / exercise data. And now we should be, so bash returned that desktop shell lesson data exercise data does not exist, and it said that because I had a typo. So we're going to try that one more time. So we're going to say cd desktop shell lesson, oh my goodness, lesson data / exercise data. Now it should show, I'm going to type in pwd, and it's going to show that we are in fact in our desktop shell lesson data exercise data. So we did it. We got to where we wanted to go. Check that we've moved to the right place, and now we can check by also using ls-f, and that will return the same list that we saw last time. So far, when specifying directory names or even a directory path as above, we've been using relative paths. When you use a relative path with a command like ls or cd, it tries to find a location from where we are rather than where the root of the file system. However, it is possible to specify the absolute path to a directory by including its entire path from the root directory, which is indicated by leading slash. The leading slash tells the computer to follow the path from the root of the file system, so it always refers to exactly one directory no matter where we are when we run the command. So this allows us to move our shell lesson data directory from anywhere on the file system, including inside exercise data. To find the absolute path we're looking for, we can use pwd and then extract the piece we need to move from, and then extract the piece we need to move to shell lesson data. So pwd, cool. So then we can use cd users sorry, I had a mint, so I'm munching on an Altoid right now. So I've just typed in my information for what they had listed. So users / or for me it's home / unleash a dragon / desktop / shell lesson data. So I'm going to hit enter, and now we are there. I'm going to actually pull this down slightly so that it's a little larger for us, and then make sure that that's up. Cool. Yeah. Okie dokie. And now we can run pwd and ls-f to ensure that we are in fact where we think we are. So pwd and ls. Cool. So I guess you can't actually combine pwd and ls-f, but that's fine. We'll just run them at different times. So the shell interprets a tilde, the wavy character, at the start of a path to mean the current user's home directory. For example, if null's home directory is users \null, then tilde data is equivalent to users null data. This only works if it is the first character in the path. Here, there, and then elsewhere is not here, there, users null, elsewhere. Another shortcut is the dash character. CD will translate dash into the previous directory I was in, which is faster than having to remember then type the full path. This is a very efficient way of moving. Sorry, every time it's making that noise, it's telling me that OBS is disconnected and reconnected. That's why it's making so many noises. But we're finishing up here soon, so hopefully, yeah. Okay, if you execute cd back twice, you'll end up in the starting directory. The difference between cd ... and cd- is that the former brings you up while the latter brings you back. So if you had already moved up out of your current directory, you could use back to get further back into the lower or the nested file directory. So let's try it. We're going to type in here cd tilde / desktop. Helps if I spell right. Desktop / shell lesson data. Cool. Now we should be in shell lesson data, and now we're going to go cd exercise data creatures. And we should now be in exercise data / creatures. But now we're going to go back one. Now we're back in shell lessons data. Yay! Cool. You'll see you're back in shell lesson data. Run cd again, and you're back in exercise data creatures. So we're going to do it again. Great. And we'll just go back and forth between those because those are the last two files in which we were. So absolute versus relative paths. So starting from users Amanda data, which of the following commands could Amanda use to navigate to her home directory, which is users Amanda? So she could just type cd. So number 8 is a solution. She could also, I believe, do this one. And let's check our solution. So dot is our current directory. That's a no-go. / is the root directory. That's a no. Okay, so we cannot use number 3, I had said. We cannot use it. That's Amanda's home directory, not home, because hers looks like this instead of like this. That was a little syntax error on my part. Number 4, cannot do it. It goes up 2 levels. And then tilde, it stands for the user's home directory. So in this case, user / Amanda, that would work. cd home, it would navigate into a directory home in the current directory. If it exists, it would not go above the current directory, which is what we're trying to do. So tilde / data / ... would work, but it is unnecessarily complicated. And then cd goes directly, that's what I would use, and then cd also just goes one up, which she's only one directory removed from users / Amanda, so she could use that to get back to users / Amanda. Now relative path resolution. So using the file system diagram below, if PWD displays, so that's our current working directory, it displays users \thing, or users/thing, sorry, my bad. What will ls backup display? So I'm thinking it's 4. I think that it'll display 4 because ... is bringing us back one directory and then forward into this backup. And so I believe it'll show original PNAS final, which is number 4 listed here. Let's see if that is correct. So yes, so ... refers to users backup and will then display what is within that directory. So ls reading comprehension, if using the file diagram below, if print working directory displays users backup, so we are in users backup, R tells ls to display things in reverse order. What command will result in the following output? So that is in that order. So PNAS sub, PNAS final, and then original. And so that would be ls rf. Yes. So ls without directory arguments lists files and directories in the current directory. And then yes, it uses the absolute path explicitly. So even if we were not in users slash backups, we could use lsrf in order to list the directories within users backup by calling it, by telling the command line to call on it. Alright, so general syntax of a shell command. We have now encountered commands, options, and arguments, but it is perhaps useful to formalize some terminology. Consider the command below as a general example of a command, which we will dissect into its component parts. So the $sign is the prompt. It tells the command line that we're trying to do something. ls is our command, and then f is an option, and / is an argument. So ls is the command with an option and an argument. Fancy things. We have already encountered options which either start with a single dash or 2 dashes, and they change the behavior of a command. Arguments tell the command what to operate on. So if you'll remember, when we called on that directory in the above example, and it produced the list of directories within that directory. Sometimes options and arguments are referred to as parameters. A command can be called with more than one option and more than one argument, but a command doesn't always require an argument or an option. You might sometimes see a bug. You might sometimes see options being referred to as switches or flags, especially for options that take no argument. In this lesson, we'll stick to using the term option. Each part is separated by spaces. If you omit the space between ls and f, the shell will look for the command called lsf, which doesn't exist. Also, capitalization can be important. For example, ls-s, lowercase, will display the size of files and directories alongside the name, while ls-S will sort the files and directories by size as shown below. cd tilde desktop shell lesson data, ls exercise data, 4 animal counts, 4 creatures, 12 numbers, 4 proteins, 4 writing. And then ls sort, animal counts, creatures, proteins, writings, numbers. Putting that all together, our command above gives us a listing files of directories in the root directory. For example, an example of the output you might get from the above command is given below. Cool. So back to Nell's pipeline. Knowing this much about files and directories, Nell is ready to organize the files that the protein assay machine will create. She creates a directory called North Pacific Gyre to remind herself where the data came from, which will contain the data files from the assay machine and her data processing scripts. Each of her physical samples is labeled according to her lab's convention with a unique 10-character ID, such as NE01-729A. This ID is what she used in her collection log to record the time, location, depth, and other characteristics of the samples, so she decides to use it as a part of each file's name. Since the assay's machine's output is a plain text, she will call her files NENE01729A.txt, and so on. All 1,520 files will go into the same directory. Now, in her current directory, shell lesson data, Nell can see what files she has using the command ls North Pacific Gyre. That's a lot to type, so she can let the shell do most of the work through what is called tab completion if she types ls nor. Oh, I need to go to cd desktop shell lesson data. Now that I'm in there, I can now run ls nor. No. Okay, so I'm in the right directory. I just don't have the one that... No, I do. I should have it. I'm going to type all of it. There we go. And then tab, and then it auto-completes. There we go. I just needed to continue reading. Imagine that. Alright. Pressing tab again does nothing since there are multiple possibilities. Pressing tab twice brings up a list of all the files. If Nell adds G, then presses tab again, she will append goo. Since all files start with goo, share the first 3 letters goo. So I can do ls nor tab G tab and then enter. But this says no such directory exists. Oops. Oops. So ls nor tab G tab. Still did not work for me. Pressing tab again does nothing since there are multiple possibilities. Pressing tab twice brings up the list of all the files. So, ls nor tab. Tab tab. G tab. Tab tab. Haha, we did it. We did it. It was just not spamming the button enough. Cool. This is called tab completion, and we'll see it in many other tools as we go on. So the key points to take from this. File system is responsible for managing information on the disk. Information is stored in files, which are stored in directories or folders. Directories can also store other directories, which is then a directory tree. PWD prints the current working directory. LS prints a list of a specific directory or file. LS on its own lists the current working directory. CD path changes the current working directory, and then most commands take options that begin with single dash. Directory names in a path are separated with slash on Unix but backslash on Windows. Slash on its own is the root directory of the whole file system. An absolute path specifies the location from the root of the file system. A relative path specifies a location starting from the current location. Dot on its own means the current directory. Dot dot means the directory above the current one. Okay, so now that we've finished all that, I'm going to mark off that we have completed navigating files. OBS is disconnected again and reconnected again, so that's fun, but I'm going to exit out of our materials here, so I'm going to exit out of the command line. Go ahead and close window, and then we are going to close this, and we're going to close this, and power off our machine. So, thank you for sticking along for the ride. I'm really hoping, I'm going to put myself in the center. I'm really hoping that I can maybe get an Ethernet cable that will help the next stream to not be so sad. That would be great. And yeah, so I will see you in the next one, and hopefully have some progress for that in terms of stream quality. I think that we've made some good progress. Like, starting to work through the command line stuff feels really great, and I'm excited for next time to keep chipping away at that. Yeah, so that's all. See you in the next one. If it'll let me. Oh no. Stop.